So let's have a quick recap. So in arithmetic mean, we have said that arithmetic mean is basically sum of observations divided by number of observations. We have discussed different methods of computing arithmetic mean, direct method, shortcut method, and step deviation method. And afterwards we have discussed different concepts of arithmetic mean like combined arithmetic mean, correcting incorrect values of arithmetic mean, and we have discussed various properties of arithmetic mean and merits and demerits. The second average that we have discussed in the last class, that is geometric mean. So we are discussing it, so we'll continue with that. Geometric mean is nth root of product of n items. So that means if we have 2 items, then geometric mean is basically square root of product of 2 items. If we have 3 items, then geometric mean is cube root of product of 3 items. And if there is n items, then geometric mean is nth root of product of n items. So we have formulated the formula of geometric mean by taking log of the expression. So I have already discussed you कि if there is an individual series, then formula for geometric mean is anti-log of summation log x upon n. And if it is a discrete series, then formula is anti-log of summation f log x upon summation f. And if it is a continuous series, then formula is anti-log of summation f log m upon summation f. So we have solved various questions of individual, discrete and continuous series to find out geometric mean. So I have already explained you how to calculate log of a number. So if you want to calculate log of a number, you have to follow 3 steps. The first step is press square root 19 times. The second step is subtract 1. And third step is multiply 227695. And then antilog is basically inverse of log. So whenever you compute antilog, you compute the antilog of log of item. So if you want to calculate antilog, you have to execute all the 3 steps but in reverse order. Like first we'll divide by 227695. Then second step we'll do add 1. And third step we'll find out power, and for power we'll press multiply equal to 19 times. So this is the process of finding the log and antilog of a item. So we have discussed questions of individual, discrete and continuous. Next concept I have explained you about combined geometric mean. Like if we have series 1 and series 2, we have been given number of items of series 1 and 2. We have been given geometric mean of series 1 and 2. And we have to find out the combined geometric mean of both the series. So I have explained you the formula. So formula is anti-log of n1 log of geometric mean 1 plus n2 log of geometric mean 2 upon n1 plus n2. So this is the process of computing combined geometric mean. The next concept we have discussed, that is correcting incorrect value of geometric mean. Like we have committed certain mistakes while computing geometric mean. So now we have to rectify the mistake. So I have already explained you have to follow 3 steps. The first step is find out incorrect summation log x. So for incorrect summation log x, what you have to do, you have to multiply number of items with log of geometric mean. So n into log of geometric mean. Second step, you have to find out correct summation log x. For that you have already find out incorrect summation log x. So from incorrect summation log x, you have to subtract the log of incorrect item and you have to add the log of correct item. So by this process you will get the correct summation of sum of log of items. Now you have to find out correct geometric mean, and the formula for correct geometric mean is antilog of correct summation log x upon n. Now let's do this question. In the last class we have discussed this question in a very fast forward manner. So let's continue that. So geometric mean of 10 observations on a certain variable was calculated as 16.2. So this is the geometric mean of 10 observations. It was later discovered that one of the observations were wrongly recorded as 12.9. So this is the wrong item, where the correct item is 21.9. So you have to apply the correction and you have to find out the correct geometric mean. So again we have to follow these 3 steps. First is incorrect summation log x. So for that what we'll do, we'll say n, that is 10 multiplied by log of 16.2. So we have computed log of 16.2. Again the same process, 16.2 square root 19 times. So this is square root 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Then subtract 1, then multiply 227695. So this will be 10 into 1.2095. This is equal to 12.095. So now we have to find out correct summation log x. For that, the incorrect summation log x, from incorrect summation log x we have to subtract the log of incorrect item, that is 12.9, and we have to add the log of correct item, that is 21.9. So let's find out the value. 12.095 minus log of 12.9. So this will be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 minus 1 into 227695. So this will be 1.11059 plus then 21.9 I'm just calculating the log. So this will be 1.3404. So adding this value in 12.095 and subtracting this 1.11059, we get this is 12.32485. So now we have to find out correct geometric mean. So correct geometric mean is antilog of correct summation log x divided by number of items. So we have divided this by 10. Now we have to find out antilog. So divide 227695, then plus 1, then multiply equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19. So our answer is 17.079. So this will be your answer. Clear? So this is how to correct the incorrect geometric mean. Now the next most important thing is properties of geometric mean. So the first property is if all the observations are constant, like suppose we have been given X series and all the items are 10, 10, 10, 10, 10. This property we have discussed in arithmetic mean as well. So if all the items are constant, then arithmetic mean of that series is also 10 and geometric mean of that series is also equal to 10. Second property is log of geometric mean is simple and weighted arithmetic mean of log of items. So when I formulated the formula, I have told you that log of geometric mean is summation log x upon n. So this is called arithmetic mean of log of items. So log of geometric mean is simple arithmetic mean of log of items. Third property is, now suppose we have two series x and y. Suppose the series has 4, 16 and 64. This series is 5, 25 and 125. So geometric mean of x series is, if we compute, this becomes 16, and geometric mean of y series is 25, because cube root of 4 into 16 into 64, this becomes 16, and cube root of 5, 25 and 125, this becomes 25. So now if we want to find out the geometric mean of product of these two series, that means we have to find out the geometric mean of 20, 400 and 64 into 125, this becomes 8000. So if we want to find out the geometric mean of this series, then we don't need to find out geometric mean this way. We can say geometric mean of xy, that is equal to geometric mean of x into geometric mean of y. So geometric mean of x is 16 and geometric mean of y is 25. So our answer is 400. So if you compute the geometric mean of this series, you have the same answer, that is 400. Similarly, if we want to find out the geometric mean of division of two series, x upon y, so that means you have to find out geometric mean of x upon geometric mean of y. So your answer is 16 upon 25. So these are the properties of geometric mean. Next, application. This is very important, ki the scenario where we apply geometric mean. So whenever you have to find out average rate, either that of increase or decrease. So whenever you have to find out average rate of increase or decrease, like average rate of increase in population, average rate of increase in production, average rate of increase in sales, average rate of increase in investments, and average rate of decrease in asset depreciation. So whenever you have to find out average rate of increase or decrease, in that case you use geometric mean. So it helps in finding out average ratio, average rate, percentage, and the most important is geometric mean helps in computing relative change. Relative change means change in relation to some other factor. So whenever you have to find out relative change, the geometric mean is the ideal average. So that is why geometric mean is used in computing index number, because index number basically measures relative change, and for relative change the ideal measure is geometric mean. So these are the applications of geometric mean, the areas where we apply geometric mean. So whenever you have been given population of different years and you have to find out average rate of population increase, then you will use geometric mean. You have been given asset and the rate of depreciation and you have to find out the rate of decline, then you will use geometric mean. So this is the possible scenarios where we apply geometric mean. So this is our second average, that is geometric mean. Now third one, we'll move to our third mathematical average, that is harmonic mean. I have already explained you that there are two types of averages. One is mathematical and second is positional. So in mathematical we have three types of averages: arithmetic mean, geometric mean and harmonic mean. Arithmetic mean and geometric mean I have already explained. Now the third average we are explaining, that is harmonic mean. So first understand the definition of harmonic mean. So what is harmonic mean? So in the definition itself we can identify the formula. So harmonic mean is invert reciprocal of arithmetic mean. Now what do you mean by reciprocal of arithmetic mean? Our formula for arithmetic mean is summation x upon n. So when we are talking about reciprocal of arithmetic mean, then it becomes n upon summation x. So harmonic mean is reciprocal of arithmetic mean of reciprocal of items. Means you have to reciprocal the item, inverse. So that means our formula for harmonic mean is n upon summation 1 upon x. Means the first thing you have to reciprocal the formula for arithmetic mean, and second thing you won't take the items as it is, you have to take the reciprocal of items. So suppose if we have items x1, x2, x3, x4 and we have to find out harmonic mean of these items. So we have number of items 4. So first we'll compute 1 upon x, means reciprocal of items. So 1 upon x1, 1 upon x2, 1 upon x3, 1 upon x4. So harmonic mean is equal to n means 4, 4 upon 1 upon x1 plus 1 upon x2 plus 1 upon x3 plus 1 upon x4. So this is the formula for harmonic mean. So let's identify the formulas for individual, discrete and continuous. So individual series in which there are just items. So formula for harmonic mean is n upon summation 1 upon x. When we are talking about discrete series, here number of items are replaced by frequency. So formula for harmonic mean in discrete series is summation f upon summation f upon x. And in case of continuous series, where instead of x we have mid value, so formula is summation f upon summation f upon m. So these are the formulas of harmonic mean in different types of series, that is individual, discrete and continuous. So let's solve the questions of these series. So first thing, calculate harmonic mean of the following series. So this is the series that has been given to us. So as we see, this is an individual series. So first thing we have to find out 1 upon x. That means 1 upon 3, 1 upon 5, 1 upon 6, 1 upon 6, 1 upon 7, 1 upon 10 and 1 upon 12. So you can take it in decimals. So 1 upon 3 is 0.3333. Take at least 4 decimal places, otherwise there is a huge difference in your answers. 1 by 5 is 0.2. 1 divided by 6, that is 0.1667. Again 0.1667. 1 divided by 7, we have 0.1429. Then 1 upon 10, this is 0.1. And 1 divided by 12, this is 0.0833. Now our formula for harmonic mean is, that is n upon summation 1 by x. So total number of items are 7. So 7 divided by sum of these items. So let's sum it. 0.1, 0.1429, 0.1667 plus 0.1667 plus 0.2 plus 0.3333. So this will be 1.1929. So this is 7 divided by 1.1929. So our answer is 5.868. So this is our harmonic mean in case of individual series. Now let's move to the next question. Now as we see, this is a discrete series in which marks is x and number of students is frequency. So we have to calculate harmonic mean. So formula for harmonic mean in discrete series is summation f upon x. So that means we have to find out first f upon x. So this is 4 by 20, 2 by 21, 7 by 22, 1 by 23, 3 by 24 and 1 by 25. So this is f upon x. So first write down the values. So 4 divided by 20, this is 0.2. 2 divided by 21, this is 0.0952. 7 divided by 22, this is 0.3182. 1 divided by 23, this is 0.0435. Then 3 divided by 24, this is 0.125. And 1 divided by 25, this is 0.04. So now we have to add it. This becomes 9, 5, 8, 13, 3, 16, 5, 21, 11, 12, 16, 18, 22, 4, 7, 8. So this is 0.8219 and sum of frequency is 18. So harmonic mean is 18 divided by 0.8219. So 18 divided by 0.8219, this is equal to 21.9. So harmonic mean of this series is 21.9. Now third one, this is continuous series. So in case of continuous series, first we have to compute mid value. So mid value of this series is 5, 15, 25, 35 and 45. So this is number of students, that means this is a frequency. So formula for harmonic mean in case of continuous series is summation f upon summation f upon m. So summation f is, this is 7, 4, 11, 19, 21, 30, 60. So this is 60 upon, so first we have to find out 4 upon 5, 7 upon 15, 28 upon 25, 12 divided by 35 and 9 divided by 45. So this is 0.8, 7 divided by 15, this is 0.4667, 28 divided by 25, this is 1.12, 12 divided by 35, this is 0.3429 and 9 divided by 45, this is 0.2. So now we have to add it. This is 16, 7 to 9, then 6 to 8, 4, 12, 9, 13, 14, 17, 19. So this is 2.9296. So 60 divided by 2.9296. So 60 divided by 2.9296, our answer is 20.48. This is the harmonic mean. So next again, harmonic mean is of two types. One is simple harmonic mean and second is weighted harmonic mean. Mathematical averages, whether it is arithmetic mean, geometric mean, harmonic mean, these three averages are both classified as simple mean average and weighted average. So I have already explained you, when all the items have equal weightage, everyone is looking in the same manner, in that case we compute simple average. But if every item has different weightage based on their importance, then we compute weighted harmonic mean. Like we computed weighted arithmetic mean, so formula is summation wx upon summation w. If we compute weighted geometric mean, so formula is antilog of summation w log x upon summation w. And if we are computing weighted harmonic mean, so our formula is summation w upon summation w upon x. So this is the formula for weighted average. Now again in this case, this marks is x and weights are w. So first thing we have to find out w upon x. So 1 by 4, this is 0.25. 2 by 7, this is 0.2857. Then 1 divided by 12, this is 0.0833. 1 divided by 19, this is 0.0526. And 1 divided by 25, this is 0.04. So just add them. So we have added them. 16, this is 6, 9, 11, 6, 8, 14, 8, 22, 27, 31. Sorry, it's there is a mistake in this. 0.25 plus 0.2857 plus 0.0833, 0.0526, 0.04. So this is 0.7116. So now sum of weights is 2, 3, 4, 5, 6. So 6 divided by 0.7116. So 6 divided by 0.7116, our weighted harmonic mean is 8.43. So this is weighted harmonic mean. Now next thing is properties of harmonic mean. So the first property we have discussed in arithmetic mean as well as in geometric mean. If all the items are same, say 10, 10, 10, 10, then harmonic mean of that series is also equal to 10. That means if there are items which are alike, same, in that case arithmetic mean is equal to geometric mean equals to harmonic mean, that is equal to k, if all the items are same. And if all the items are different, then the relationship is quite different. If all the items, this is the first thing, when all items are same. When all items are same. And second thing, when all items are different, distinct. When all items are distinct, then the relationship between AM, GM, HM, AM is greater than GM is greater than HM. Means the largest value is of arithmetic mean, then geometric mean and harmonic mean. So first property is if all the items are same, say constant k, then harmonic mean is equal to k. And if you want to find out combined harmonic mean, similar to combined arithmetic mean, combined geometric mean. So formula for combined harmonic mean is n1 plus n2 upon n1 upon harmonic mean 1 plus n2 upon harmonic mean 2. Now suppose we have series 1 in which there are 3 items and the harmonic mean of that series is suppose 4. Second series in which items are 5 and harmonic mean is 8. So we have to find out combined harmonic mean. So formula for combined harmonic mean is n1 plus n2. n1 upon harmonic mean 1 plus n2 upon harmonic mean 2. So simplify it, 8. So this is 6 plus 5, 11. So answer is 64 by 11. So this is the combined harmonic mean. So these are the properties of harmonic mean. Now the next thing is applications of harmonic mean. Applications. In which scenario? Because all these are considered as average. Arithmetic mean is also an average. Geometric mean is also an average. Harmonic mean is also an average. So you must know the scenario where we compute arithmetic mean, harmonic mean and geometric mean. So I have already explained you that whenever you have to find out rate percentage, then we compute geometric mean. In case of rate percentage, we compute geometric mean. And harmonic mean is whenever you want to compute average speed, average time, average price. So these are the possible scenarios where we compute harmonic mean. So whenever you have to compute average speed, you have to consider distance. If distance is constant, whenever we want to compute average speed, our main factor is distance. The main factor is distance. If distance is constant, every time you are covering the same distance, then we compute simple harmonic mean. And if distance varies, then we compute weighted harmonic mean and we take distance as weights. So in average speed, second is average time. Suppose you have been given that a piece of work is done by A in 5 minutes, B in 6 minutes, C in 4 minutes. So you have to find out the average time. In that case, you have to compute simple harmonic mean. And third is whenever you have to compute average price. So the best average for computing average price is arithmetic mean. So the possible scenario where we use harmonic mean is when total expenditure is given. When total expenditure is given, then we compute harmonic mean. If total expenditure is constant, every time you are spending same amount, then we use simple harmonic mean. And if it varies, every time your total expenditure is different, then we use weighted harmonic mean. And the total expenditure becomes the weights. So this is the application of harmonic mean. So harmonic mean is best considered for average ratio. So whenever we have to compute average ratio, the ideal average is harmonic mean. So relationship I have already explained you. Ki relationship means between AM, GM and HM. So while computing the relationship, you have first find out whether alike items or distinct items. If all the items are alike, then AM equals to GM equals to HM. If the question says all the items are distinct, then you say AM is greater than GM is greater than HM. And if nothing has been mentioned about items, nothing has been mentioned about nature of items, that they are same or distinct, in that case arithmetic mean is greater than equal to geometric mean is greater than equal to harmonic mean, then you have to click on this option. So this is very tricky. Make sure you must remember, if the question has said for alike items, the relationship between AM, GM and HM is all three are equal. If the question says for distinct items, then relationship is AM is greater than GM is greater than HM. And third is when nothing has been mentioned about the nature of items, whether they are alike or distinct, in that case you will say AM is greater than equal to, GM is greater than equal to HM. And if there are just two items, only two items, say A and B, so in that case the relationship between AM, GM and HM is GM is equal to square root of arithmetic mean into harmonic mean. Geometric mean is equal to square root of arithmetic mean into harmonic mean. So I'll prove this. Suppose I have two items A and B. So arithmetic mean of two items is sum of items divided by number of items. Geometric mean is square root of product of two items. And harmonic mean is number of items divided by sum of reciprocal of items. So this becomes AB, A plus B. So harmonic mean becomes 2AB upon A plus B. So now my expression says geometric mean is equal to square root of arithmetic mean into harmonic mean. So I took right hand side and I just equated the value of arithmetic mean and harmonic mean. So arithmetic mean is A plus B upon 2. Harmonic mean is 2AB upon A plus B. So A plus B cancel, 2 cancel. This is equal to square root of AB, which is equal to geometric mean, means left hand side. So in case of two items, the relationship between GM, AM and HM is geometric mean is square root of product of arithmetic mean and harmonic mean. So let's do a question to explain this. If the arithmetic mean between two numbers is 10, that means mean is equal to 10 and geometric mean is 8. So geometric mean is equal to 8 and we have to find out harmonic mean. So I have already explained you कि in case of two numbers, geometric mean is equal to square root of arithmetic mean and harmonic mean. So geometric mean is 8, arithmetic mean is 10 into harmonic mean. Squaring both sides because we have to cancel the square root. So we have to take squaring both sides. So this becomes 64 equals to 10 harmonic mean. So harmonic mean is equal to 6.4. So this is the way we can compute anything, either arithmetic mean, harmonic mean or geometric mean. Now next case is you have to find out the numbers as well whose arithmetic mean is 10, geometric mean is 8. So I have told you that arithmetic mean is a plus b upon 2, that is equal to 10, and geometric mean is square root of ab, that is equal to 8. So I have got two equations, a plus b equals to 20 and squaring both sides ab equals to 64. Now simply take the value of a, that is equal to 20 minus b, and substitute this value in this equation. b 20 minus b equals to 64. So this is 20b minus b square equals to 64. So forwarding the entire equation on right hand side, we get b square minus 20b plus 64 equals to 0. 16 4s are 64. So minus 16b minus 4b plus 64. We have splitted the middle term so that we can get the roots of this quadratic equation. So this is b common, b minus 16 minus 4 common, b minus 16. So we got the value of b 16 and another value of b 4. So if one value of b is 16, then definitely a is 4 because a plus b equals to 20. And if we took value of b as 4, then definitely a is 16. So these are our answers. So this is how we have discussed various mathematical averages, arithmetic mean, geometric mean and harmonic mean. So I hope everybody is clear, everybody has understood the concepts of these three averages. So now our next average is positional averages. I have told you positional averages are those which are based on position of item in the series. That item lies on which position. Here the position matters, not the magnitude of item. So average which is based on position of item in the series, this is called positional averages. And we have divided into two parts. One is partitional averages and second one is mode. So let's discuss all these averages. So first I am discussing partitional averages. Partitional averages are those averages that divide the entire series into partitions. Divide the series into different parts. So the averages that divide the series into parts, this is called partitional averages. So in case of partitional averages, we have basically four averages. We have median, we have quartiles, we have deciles and percentiles. So these four are our partitional averages. First of all, understood the meaning of these partitional averages. Median. median, divide the entire series into two equal parts. Divide the entire series into two equal parts. So that means if this is this number line of my series which is arranged in ascending order, so the mid value, this is called median. So we'll say median is called mid value of the series. It divides the entire series into two equal parts, 50% on this side and 50% on this side. So we say कि 50% items are less than equal to median and 50% items are greater than equal to median, because median participates in both parts. So that is why we always use less than equal to or more than equal to. This is called median. So when we talk about quartiles, quartiles are which divide the entire series into four equal parts. Entire series into four equal parts. So let's say, suppose this is my series in a ascending order. So we have four parts. This is Q1, this is Q2, this is Q3. So this is my first quartile, this is my second quartile, this is my third quartile, and this is my fourth quartile. So basically quartiles divides the entire series into four equal parts. So we say Q1 comprises of 25% of items. Q2 comprises of 50% of items. So it's basically another name of median. And Q3 comprises of 75% of items. And Q4 100% of items. So when a particular average comprises of 100% of items, then there is no utility of that. So whenever we compute quartiles, we just compute two quartiles. One is Q1 and another is Q3. Q1 25% items are less than equal to Q1 and 75% items are greater than equal to Q1. Similarly, in case of Q3, 75% items are less than equal to Q1 and 25% items are greater than equal to Q3. So this is called quartiles. Next we have deciles. Deciles divide the entire series into 10 equal parts. Divide the entire series into 10 equal parts. So that means if this is a series, so D1, D2, D3, D4, D5 up to D6, D7, D8, D9, D10. So this is called deciles that divides the entire series into 10 equal parts. Now again, D1 comprises of 10% of items, D2 comprises of 20% of items, D3 comprises of 30% of items, and so on. So D10 comprises of 100% of items. So whenever we compute decile, we compute D1 to D9, where D5 that is equal to median because it comprises 50% of items. So next we have percentile. Percentile divides the entire series into 100 equal parts. Divides the entire series into 100 equal parts. So that is why from percent we have taken the name percentile. So when we talk about percentile, so it starts from P1, P2 up to P100. But P100 comprises of 100% data. So that is why whenever we compute percentile, we compute till P99. So again, P25 is equal to Q1, P10 equals to D1, P20 equals to D2, P30 equals to D3, and we say P50 equals to D5 Q2 equals to median, and so on. So this is basically the concept of percentile. So I hope this is clear ki what are different partitional averages. So they are basically classified as basing on the basis of number of partitions. So median has 2 partitions, quartile has 4 partitions, decile has 10 partitions, and percentile has 100 partitions. So how we can compute these averages? So first we'll take the example of individual series. So let's do it. First we took the example of individual series. So I'll give you the chart how you can find out the method through which you can find out the values of these partitional averages. So let's make a chart for that. So let's say, so we'll compute partitional averages. Partitional averages. So we are computing partitional averages in case of individual series. So this is our individual series. So let's say first thing is you have to arrange the series in ascending order. So the most important thing is arrange the series in ascending order. So we have to arrange all the data in ascending order. Second thing is you have to find rank of partitional averages. Find rank of partitional average. So now how to find out rank? If we are finding the rank of median, then finding the rank is n plus 1 by 2. If we are trying to find the rank of quartile, I am saying QK. K represents index. If we are computing first quartile, then K becomes 1, and if we are computing third quartile, then K becomes 3. So how to find out rank of quartile? So this is equal to K n plus 1 by 4. Similarly, if we want to find out the rank of decile, this is K n plus 1 by 10. And for percentile, it's K n plus 1 by 100. So this is the formula of finding the rank. So first we find out the rank. Second, next step is, if rank is integer, then value at corresponding position is partitional average. Now what it means, here n is number of items. Now suppose number of items is 11 and we are finding out median. So rank of median is 11 plus 1 by 2, that is 6, which is an integer. So item which is lying at 6th position, that is your median. Similarly, if we are finding out Q1, so that means 11 plus 1 by 4, that means 3. Third item is your quartile Q1. If we are finding out Q3, then it becomes 11 plus 1 by 3 into 11 plus 1 by 4, that means 9. That means 9th item is your Q3. So this is the scenario when rank is an integer value. And if rank is real number, means it is in decimals, then how we can find out the partitional average? So this is, partitional average is item at rank position plus item at next position minus item at rank position multiplied by decimal portion. Now what it means, suppose n is equal to 12. So rank is equal to rank of median, that is equal to n plus 1 by 2, that means 12 plus 1 by 2. So this becomes 6.5. So now how we can find out median? Item at integer part of rank position, integer part of rank position means item at 6th position plus decimal part is 0.5, item at 7th position minus item at 6th position, means the decimal part is multiplied by the difference of the rank item, integer position of integer part of rank item and the next item. The difference of that items is multiplied by your decimal part. So that means whatever the item is lying on 6th position, we take it, and the difference of 7th and 6th item is multiplied by the decimal value. So let's do the question that will make us more clarity about this concept. So I am again changing the screen, which we are again shifting to our old screen. Let's do it. So suppose this is our first question. So as we know, this is individual series. So I have given you the steps. The first step is arrange the items in ascending order. So we have to arrange these marks in ascending order. So according to the ascending order, the first one is 7, then 10, 12, 15, 18, 20, then 25, then 38 and then 45. So this is the ascending order. So total number of items will be, this is 3, 3, 6, 3, 9, 9 items. Now first thing is I want to find out the rank. Second step, rank. So if I want to find out median, so rank of median is n plus 1 by 2, that is 9 plus 1 by 2, that is 5. That means item at 5th position, 1, 2, 3, 4, 5. So my median is 18 because this is the item which lies on 5th position. So here position matters. So whatever the item that is lying at 5th position, this is a median. So our answer is 18. Second, if we want to find out Q1. So rank of Q1 is n plus 1 by 4. So this is 9 plus 1 by 4. So this becomes 2.5. Now this is a fractional value, real value. So how we can find out? Second item plus 0.5 of third minus second. So second item is 10 plus 0.5 of third item is 12 minus 10. So 10 plus 0.5 of 2, that is equal to 11. This is my Q1. So if I want to find out Q3, that is rank is 3n plus 1 by 4. So this is 3 into 9 plus 1 by 4. This is equal to 7.5. So how we can find out Q3? 7th item plus 0.5 of 8th minus 7th item. So 7th item is 3, 4, 5, 6, 7. 25 plus 0.5 of 38 minus 25. So 25 plus 38 minus 25, this is 13. 13 into 0.5, 6.5. So answer is 31.5. So next is we have to find out D8. So D8 is 8 into n plus 1 by 10. Denominator also always mention the number of parts. So if it is quartile, then denominator has 4. If it is decile, denominator has 10. And if it is percentile, then definitely denominator has 100. So 8 into 9 plus 1 by 10. So this is equal to 8. This is an integer value. So 8th item is, this is 5th, 6th, 7th, 8th. So D8 is 38. And if we want to find out P64, that means 64 into n plus 1 by 100. So this is 64 into 9 plus 1 by 100. This is equal to 6.4. So again it's in fraction. So P64 is 6th item plus 0.4 of 7th item minus 6th item. So 6th item is 20 plus 0.4 of 25 minus 20. So your answer is 22. So this is the way you can calculate various partitional averages. So depending upon if rank is integer, then simply the item that lies on that particular position is your average, and if it is in real value, then item at integer position plus the fraction part should be multiplied by next item minus rank integer position item. So this is your individual series. So this is a homework to you. Let's move to the next one. So next one will say that is discrete series. Now we'll move to the next one, that is called discrete series. So when we talk about discrete series, in case of discrete series, you have been given two things. One is x item and second is frequency, number of items, number of times a particular item is repeating. So how to find out partitional averages in case of discrete series? So first thing, again the same, arrange the series in ascending order. You have to arrange the x, not the frequency. So frequency will be adjusted accordingly. So you have to arrange the series into ascending order. X items you have to arrange in ascending order. Now second step is find CF. CF stands for cumulative frequency. That means you have to find out sum of frequencies. So second step is cumulative frequency. Third step is find rank. Rank of partitional average. So in case of discrete series, again you have to follow the same pattern but we have done in individual series. Like if we are computing the rank of median, then our formula is n plus 1 by 2. If we are finding the rank of quartile, then again k n plus 1 by 4. For decile, it will be k n plus 1 by 10. And for percentile, it will be k n plus 1 by 100. So this is, you have to find out the rank of partitional averages. So first you computed the rank. Now next step is find cumulative frequency in which rank of respective partitional average lies. Means you have to identify the cumulative frequency in which rank will lie. Corresponding item or x corresponding item or X is the partitional average. So the CF in which your rank lies, the item corresponding to that CF, that is your partitional average. That means median, Q1, Q3, anything you are finding out, that will be the respective partitional average. So this is the method how you can find out partitional average in case of discrete series. So let's have a look how we can solve this question. So say we have been given the question, this is the question. So this is your X and this is your frequency. Now this is discrete series. So first step is arrange X in ascending order. So as we see in the question, the marks are already is in ascending order. So we don't need to change the order of the marks. So next step is we have to find out CF, that is cumulative frequency, sum of frequencies. So this is 10, 15 plus 10, 25. 25 plus 25, 50, 50 plus 5, 55, 55 plus 5, 60 and 60 plus 20, 80. That means total frequency is 80. So now third step is we have to find out the rank. So whatever the partitional averages we have to solve, let's see, we have to find out median. So rank of median is n plus 1 by 2. Here n is sum of frequency, total frequency. So this is 80 plus 1 upon 2. That becomes 40.5. Q1 is equal to n plus 1 by 4. So 80 plus 1 by 4. So this will be 20.25. Next Q3, this is equal to 3n plus 1 by 4. So this is equal to 380 plus 1 by 4. So multiplied, this becomes 60.75. Then we have second decile. Second decile is 2n plus 1 by 10. So 2 into 80 plus 1 by 10. So this is 81 into 2, 162, 16.2. And then we have P89, that is 89 into n plus 1 by 100. So this is 89 into 80 plus 1 by 100. So if we multiply 89 with 81, 89 multiplied by 81. So answer is 72.09. So we have computed the rank. Now we have to find out the average. So the rank of median is 40.5. Now find the CF in which rank of median lies. This is 25, this is 50. So 25 is less than rank and 50 is more than rank. That means this cumulative frequency, this rank 40.5 lies in this CF. The corresponding X is 25. That means our median is 25. Now let's move to Q1. So Q1 is, the rank of Q1 is 20.25. So in which cumulative frequency it lies? 10 छोटा है, 25 बड़ा है. So the CF which is greater than your rank, that is the CF. The preceding one is smallest and that one is greatest. So the CF which is greatest than your rank value, that is the CF in which your rank lies. So the rank of 20.25, that means of Q1, lies in 25. So corresponding item, that means 20. So Q1 is equal to 20. Now let's move to Q3. The rank of Q3 is 60.75. That lies in 50 no, 55 no, 60 no, 80. Because 60 is less than 60.75 and 80 is greater than. So that means it lies in 80. So the item in front of that is 40. That means Q3 is equal to 40. Let's move to D2. D2 is 16.2. So 16.2 lies in 10? No, it lies in 25. So again our D2 is 20. Now next one, 72.09. It lies in 60? No, it lies in 80. So our P89 is 40. So this is how we can find out partitional averages in case of discrete series. It's very easy. You have to first arrange in ascending order, you have to find out cumulative frequency, then find the rank, simply n plus 1. If there are 2 parts, divide by 2, 10 parts, divide by 10, 100 parts, divided by 100, and 10 parts, divided by 10. And whatever the rank you are computing of partitional average, if it's 14, multiplied by 14, if it is 94, it multiplied by 94. So you have to find out rank lies in which cumulative frequency. The corresponding item of that CF will be your partitional average. So this is your discrete series. So let's move to the next one. So next one is our continuous series. So let's move to continuous series. So third one is continuous series, in which we have been given item as well as frequency, means item in the form of class intervals as well as frequency. So now what steps we have to follow? Let's move. The first step is always same, that is common in all the three series. Arrange the series in ascending order. So first thing, you have to arrange the series in ascending order. Means you have to arrange class intervals in ascending order. And you know it very well that class intervals are always in ascending order. So this is the step that we don't need to do, because class intervals are generally in ascending order. Second thing, you have to find out cumulative frequency, that is CF. Find CF, cumulative frequency, that means sum of frequencies. Now third step is find rank of partitional average. Now again there is a slight change in continuous series. Like whenever we are computing rank in individual series and discrete series, the formula for rank is same, that is n plus 1 divided by number of partitions. But in case of continuous series, there is a slight change in computing the rank. If we are computing rank of median, we'll say n by 2. If we are computing rank of quartile, that becomes kn by 4. Means whatever we are adding plus 1. Now in case of continuous series, we don't need to mention plus 1, we simply say n, and n is equal to sum of frequency. So for median it's n by 2, for quartile it's kn by 4, for decile it's kn by 10, and for percentile it's kn by 100. So this is how we can find out the rank of partitional average. Now next step, again the same. Find CF, cumulative frequency, in which rank of respective partitional average lies. So you have to find out the CF, cumulative frequency, in which the rank lies. Now in case of discrete series, we simply say the corresponding item will be your partitional average. But in continuous series, corresponding class interval will be the class in which respective partitional average lies. In which the respective partitional average lies. So in case of discrete series, we get the answer at this point, but in continuous series, we won't get the exact answer, we get the class interval in which our partitional average lies. So we have to use one formula to calculate the exact value of partitional average. We got the class interval in which our item lies. So how to calculate? So if we are computing median, so formula is L1 plus rank minus CF upon F into I. This is a journal formula for computing any partitional average. Partitional average. Now I'll explain it. So L1 is lower limit of partitional average class. The class in which your partitional average lies, the lower limit of that class is called L1. Rank is your rank of partitional average, which we have computed it, n by 2, n by 4, kn by 4. So this is rank of partitional average. CF stands for cumulative frequency of previous class. Means the class in which your partitional average lies, the previous class, CF of previous class, that is your cumulative frequency, which you have to mention here. And F is frequency of partitional average class. The class in which your partitional average lies, the frequency of that class is F. And I is class interval of partitional average class. Class interval of partitional average class. So suppose your partitional average class is 20 to 30. So class interval is 10. If it is 20 to 25, so class interval is 5. So this is the scenario. If you have unequal class interval, then you have to take the class interval of the class in which your partitional average lies. If you have equal class interval, then all the class intervals are same. So this is the formula. So if I want to find out median, so my formula becomes L1 plus n by 2 minus CF upon F into I. If I want to find out quartile, so my formula is L1 plus Kn by 4 minus Cf upon F into I. If I want to find out decile, so formula is L1 plus Kn by 10 minus Cf upon F into I. And if we are finding percentile, then formula is Kn by 100 minus Cf upon F into I. So this is the formula of finding partitional average in case of continuous series. So it's quite lengthy, but it's very easy. If you understood the concept, then you can easily solve it. So let's solve one question. This will help you reminding all the concepts. Come on, let's start it. So we have the question of continuous series. Now this is the continuous series in which we have been given class interval as well as the number of students. So let's start. So first thing, ascending order. The class intervals are already in ascending order. Second thing, cumulative frequency. So let's find out cumulative frequency. So cumulative frequency is 8, 38, 78, 90 and 100. That means total frequency is 100. So first I want to find out median. So that means I have to find out rank of median. So formula for rank, let's say we'll compute the similar way, we'll find out the rank of all the partitional averages. So first thing, rank of median. this is equal to n by 2. So n is 100, so rank of median is 50. Rank of Q1 is n by 4, that is 100 by 4 equals to 25. Rank of Q3, that is 3n by 4, that is 3 into 100 by 4, which is equal to 75. Then D8, this is 8n by 10, so this is 8 into 100 by 10, so this is 80. And next is P35, that is 35n by 100, so this is 35 into 100 by 100. So first we have computed rank of all the partitional averages. Now next thing, we identify the class interval in which the respective rank lies. So 50 lies in which CF? 78. So corresponding class interval will be 20 to 30. So median lies in 20 to 30. Q1 rank is 25. So it is greater than 8 but less than 38. So it lies in 38. So class interval is 10 to 20 for Q1. Now 75. So 38 is less than 75 but 78 is greater than. So it will lie in 78. The corresponding class will be 20 to 30. D8, 80. So 80 is greater than 78 but less than 90. So it lies in 30 to 40. And 35, it is greater than 8 but less than 38. So it lies in 10 to 20. So we got the class interval in which the respective partitional average lies. Now next step is we have to find out the partitional average. So let's find out median. L1, I have already written the formula. L1, lower limit of class interval 20 plus rank is 50 minus cumulative frequency of previous class. If your class is 20 to 30, then you have to mention the CF of 10 to 20. So 10 to 20 has CF 38. Frequency of 20 to 30 class, that is 40. And class interval is, because all the class intervals are same, so class interval is 10. So we got 20 plus 50 minus 38, 12 into 10 upon 40. So our median is 23. Now let's move to Q1. Our lower limit 10 plus rank is 25 minus cumulative frequency of previous class, then 10 to 20. So 0 to 10, this is 8 upon frequency of class 10 to 20, this is 30. Class interval is 10. So this is 10 plus 25 minus 8, 17. 170 upon 30. So this will be 15.67. This is our Q1. Now let's move to Q3. Our lower limit of class interval is 20 and rank is 75. CF of previous class means 20 to 30, say previous class, that is 10 to 20, 38 upon frequency of 20 to 30, 40, class interval 10. So this will be 20 upon, this is 27 upon 40 into 10. So this will be 27 divided by 4, that is 4 6 are 24, 3, 6.75. So answer is 26.75, because if it's divide 27 divided by 4, it's 6.75. Now let's find out D8. Our lower limit is 30, rank is 80, CF of 20 to 30, that is 78 upon frequency of 30 to 40, 12 into 10. So this is 30 plus 80 minus 78, 20 upon 12. 4 5s are 20, 4 3s are 12. So this is 1.67, 31.67. P35, class interval is 10 to 20, so lower limit is 10, rank is 35, cumulative frequency of previous class means 0 to 10, that is 8, frequency of 10 to 20, that is 30 into class interval. So this will be 10 plus 27, 270 upon 30. So your answer is 19. This is how you can find out the different partitional averages in case of continuous series. I hope this is clear to you. So we have calculated partitional averages like medians, quartiles, deciles, percentiles in individual series, discrete series and continuous series. So let's move to a few complex questions of partitional average, which is basically of missing frequency, either one frequency is missing or two frequencies missing. So let's move to the first question. Find the missing frequency when median is 24. Now in this question you have been given median value and the one frequency is missing and we have to find out the missing frequency. So how we can find out the missing frequency? So first thing, again you have to follow the same steps that we generally follow in case of partitional averages. Like first thing, this series class interval should be in ascending order. They are. Next thing, cumulative frequency. So I took missing item as missing frequency as x. So my CF is 5, 30, 30 plus x, 48 plus x and 55 plus x. So second step we have done cumulative frequency. The third step is rank of median. So rank of median is, as it is continuous series, n by 2. So now I don't have total number of items. So my total number of item is 55 plus x. So my rank is 55 plus x upon 2. In the earlier questions, when there is no missing frequency, the rank helps us to identify the class interval in which our median lies. But here the rank is not complete because it's 55 plus x and we don't know the value of x. So rank won't help us in identifying the class interval in which our median lies. But the most amazing thing is we have been given the value of median. So from the value of median we can identify the class interval. So our median is 24. It means our class interval is 20 to 30. Our median lies in class interval 20 to 30. So in case of missing frequency, the value of median or partitional average explain you the class interval in which your average lies. So here rank won't help, the value itself help you in identifying the class interval. So class interval is 20 to 30. So CF of previous class is 30. Frequency of median class is x. So now we have to equate all these values into the equation, into the formula. So L1 plus rank is n by 2 minus CF upon F into I and our class interval is 10. So median, the value of median is 24, lower limit of class is 20, rank is, that is 55 plus x upon 2. Cumulative frequency is 30, frequency is x and class interval is 10. Now let's solve the equation beta. So this is 24 minus 20, क्योंकि this is a fraction, this is independent and this is independent. So first we have subtracted 20. So this becomes 55 plus x. I took 2 as LCM. So this becomes minus 60 upon x into 10. So this is 4 upon 10, that is equal to x minus 5 upon 2x. Now this becomes my equation, that is linear equation. Cross multiply it. So 8x equals to 10x minus 50 minus 2x equals to minus 50. So x is equal to 25. That means the missing frequency is 25. So this way you can easily solve the question of missing frequency. So this is the scenario when there is just one missing frequency. Let's move to next question. Now in this question there are two missing frequencies. So definitely when there is two missing frequencies, we need two parameters. So let's read the question to identify which parameters has been given to us. Find the missing frequency when median is 46. Now the first parameter is median, and if I look at the figures, the second parameter is total number of items. So again the missing frequency will be taken as x and y. So now let's solve class intervals already in ascending order. Next step is CF, cumulative frequency. So this is 12, 30 plus 12, 42, 42 plus x, 107 plus x, 107 plus x plus y, 132 plus x plus y, 150 plus x plus y. So my first equation is 150 plus x plus y. The total has been given 229. That means x plus y equals to 229 minus 150. So x plus y is equal to 79. This is my first equation. Now second equation I can formulate with the help of formula of median. Now median has been given as 46. So the value of median will let you know the class interval. So class interval in which median lies, according to the value, it's 40 to 50. So cumulative frequency of previous class, that means 30 to 40, that is 42 plus x. Frequency of median class 40 to 50, that is 65. And class interval of median class, that is 10. Simply put all these values into our formula. Median equals to L1 plus rank minus CF upon F into I. So L1 is 40 and median is 46. Now rank is n by 2. So don't take n, that is 150 plus x plus y. You have been given total value 229. So rank is 229 upon 2. So this is 229 upon 2 minus cumulative frequency is 42 plus x. Frequency is 65 and class interval is 10. So 46 minus 40, that is 6. Then plus 6 equals to 229 minus, we have taken 2 as LCM. So this becomes 84 minus 2x into 10. So this becomes 6 by 10 equals to 229 minus 84. This is 12 minus 8, 4, 145 minus 2x upon 2. So this is my equation. Just cross multiply it. 2 3 is 6, 2 5 is 10. So 6 equals to 725 minus 10x. So there is some mistake in this question. 46 minus 46 upon 10. 2 3 is 6, 2 5 is 10. So 229 minus 84 minus 2x. 9. So 2 3 is 6. So this becomes minus 10x equals to minus 719. Because 6 minus 725. So x is equal to 71.9. Now again the frequency cannot be in fractions. So we took x equals to 72. Second equation is x plus y equals to 79. if x is 72, then y is equal to 7. 79 minus 72. So this is how we can compute missing frequency in case of 2 items. Now similar is the scenario when quartiles are given. So the first quartile and third quartile. So Q1 is given, that is 25, and Q3 is given, that is 50. Total items that is given is 72. And we have 3 items are missing. So that's why we have been given 3 parameters. One is Q1, another is Q3, and third is 72. So first, class interval. Class interval of Q1 according to the value 25, this is 20 to 30. Q3 50, so it lies in 50 to 60, not 40 to 50, because this is exclusive class intervals, and in case of exclusive class the upper limit is not included in that class, it is included in the next class, so we say 50 to 60. Then bacha, next thing, rank of Q1, that is n by 4, so 72 by 4, that is equal to 18. And Q3 is 3n by 4, that is 3 into 72 by 4, that is equal to 54. So CF of the preceding class. So first find out the CF for 12. I have taken missing frequency as x, y and z. So this is 12 plus x, 19 plus 12, 31 plus x, 31 plus x plus y, 41 plus x plus y, 46 plus x plus y, and 46 plus x plus y plus z. So cumulative frequency of previous class, that is 10 to 20, this is 12, and frequency is 20 to 30, that is x. In case of Q3, cumulative frequency is 50 to 60 is your normal class, that means 40 to 50, this is 31 plus x plus y, and frequency is 50 to 60, it's 10. So simply put the values. Q1 equals to lower limit plus rank 18 minus CF of previous class upon frequency into class interval. So this is 25 minus 25 upon 10, that is 6 upon x. So we get the value of x is equal to 12. So putting the value of x in this equation, our cumulative frequency becomes 31 plus 12 plus y. So that is 43 plus y. So now Q3 is 50. Lower limit is 50 plus rank is 54 minus CF 43 plus y upon frequency is 10 and class interval is 10. So this is cancelled, 50 cancelled. So 54 minus 43 minus y equals to 0. 11 minus y equals to 0. Y is equal to 11. So now the third equation we have been given 46 plus x plus y plus z, that is equal to 72. Now just put the values of x. X is 12, y is 11. So z is equal to 72 minus 6 2 8 9 4 5 6. So z is equal to 3. So this is the value of x is 12, y is 11 and z is 3. Next one. This is a very interesting question, and certain type of questions are very much asked in the question papers, because these are quite confusing one. So just read the question carefully. The median of few observations is given to be 48.67. So the median is 48.67. So median means the mid value. So suppose if this is the series which is arranged in ascending order. So the mid value is 48.67. Few items are here and few items are here. We don't know the total number of items, but we know that the item that lies in the mid, that is 48.67. Now next line is the 6 items whose values are this were added to the given series. Now we have introduced new 6 items and included in the series. So let's write down where these items will be placed in the series. Now first item is 33.5, which is less than median, so we put it on left hand side. 38.9, again this is less than median, so we put it on left hand side. And then third one is 45.57, again less than median, so we put it on the left hand side. Next item is 49.03, which is greater than median, so definitely it will always lies on the right side of the series. So 49.03. Next item is 53.43, again greater than median, and last one is 59.95. So whatever the 6 items we have introduced in the series, they are divided equally on both sides of the series. 3 on the left hand side and 3 on the right hand side. So now we have to find out the new median. Bacha, we can just check it out ki whether the items which we have introduced in the series have affected the position of median or not. Now there are 6 items and they are equally distributed on both sides. 3 on left hand side less than median and 3 on the right hand side greater than median. Means after introducing these 6 items, there is no change in the position of median. Median again lies in between. So if the items are equally distributed on both the sides, then we'll say there will be no change in median and our new median remains 48.67. So there will be no change in median. But if while introducing the 6 items, the items are in such a nature that 4 items are on left hand side and 2 items are on right hand side, or 2 items are on left hand side and 4 items are on right hand side, then it will affect the position of a median. So if the introduction of items changed your mid position, then we'll simply say our median changed. But we can't say with accuracy what will be the new median because we don't know about the other items. How we can say that by changing the position, which one is now in the middle? So we can simply comment on ki whether the median will change or not. So in this scenario, the median will not change, but if there is unequitable distribution like 4 on left hand side and 2 on right hand side, then our answer will be median will change. But we can't say what will be the new median. So this is about partitional averages. So let's discuss the various properties of median. Beta, I have already told you that these properties are very important. We have discussed the properties of mean, we have discussed the properties of geometric mean, properties of harmonic mean. So whatever the theoretical questions they ask you in your examination, they are entirely based on properties. So you must have a clarity about each and every property. So you don't need to cram it. You just have to understand the basic concept behind the property. That's why I always give you examples on each property. Like first property, if we say of median, median can be determined graphically using ogive curves. Again, this is a very important property because you have already explained that in case of arithmetic mean, geometric mean, harmonic mean, these are mathematical averages, and mathematical averages cannot be described graphically, cannot be determined graphically, but positional averages can be determined graphically, and median can be determined through ogive curves. So you must know what are ogive curves. I have explained you when we explained continuous series that there are two types of series, less than series and more than series. Less than series and more than series. I have explained this concept in the last class when we are discussing types of continuous series. So that is cumulative frequency series, that is of two types, less than and more than. So less than is always in ascending order, less than 10, 20, 30, 40, 50. Now suppose it's 5, 12, 20, 30, 45. Now this is my less than series. More than series always in descending order. More than 0, suppose it's 45. More than 10, it's 40. More than 15, sorry, more than 20, it's 45 minus 12, that is 33. More than 30, this is 33 minus 20, 13. More than 40, sorry, this is 5, 7, 8, 10, 15. So 40, more than 0, 45, 40, 40 minus 7, 33, 33 minus 8, this is 25, 25 minus 15, 10, more than 40. So this is my less than series and more than series. Okay, so now what we have to do, we have to plot this less than series and more than series on a graph. So if I plot less than series, you know this is in ascending order, like this is 5, 7, 5, 12, 20, 30, 45. So this is my less than ogive in ascending order. More than ogive is in descending order, so it will start from 45 and it will go downstairs. This is more than ogive. So the point where less than and more than ogive intersect, this is your median point. So medians can be determined graphically with the help of ogive curves. So this is your first property. Second and the most important property, that is sum of absolute deviations. Sum of absolute deviations taken from median is always dash, that means it's minimum. So understand this property, sum of absolute deviations. Now what do you mean by absolute deviations? Absolute deviation means ignoring sign. So sum of absolute deviations taken from median, that means if I took deviations from median and for taking absolute value I put it into the mod. So sum of absolute deviations taken from median is always less than sum of absolute deviations taken from any assumed mean or mean. किसी से भी ले लो, just find out the absolute deviations. The deviations you taken from median is always minimum. Let's explain it with an example. Now suppose I have been given x. X is 5, 7, 11. ये आ गया हमारा, this is the series, this is your x series. So total number of items will be 7, 5, 12, 13, 15, 20, 2, 3, 4, 5. 5. So total will be 50. So arithmetic mean is 10. Arithmetic mean is 10. And if we find out the median, items are already in ascending order. So median is equal to, in case of individual series it is n plus 1 by 2. So this is 5 plus 1 by 2, 6 by 2, that is third item. So third item is 11. So median is 11. So first thing, let's compute absolute deviations from median. X minus 11, absolute deviation, that means putting into mod will ignore the sign. So 5 minus 11, this is 6. 7 minus 11, 4. 11 minus 11, 0. 12 minus 11, 1. 15 minus 11, 4. So sum is 6, 4, 10, 11, 4, 50. Now let's take absolute deviations from arithmetic mean. Our arithmetic mean is 10. So 5 minus 10, 5. 7 minus 10, 3. 11 minus 10, 1. 12 minus 10, 2. 15 minus 10, 5. So sum will be 16. So this is greater than this. Now take from any assumed mean. Let's say we took it from 15. So 5 minus 15, 10, 7 minus 15, 8, 11 minus 15, 4, 12 minus 15, 3, 0. So this is 25. So just took absolute deviation from any value, irrespective, apart from median. The sum of absolute deviations taken from any item is always greater than we take it from median. So this is your second property. Sum of absolute deviations taken from median is always minimum. Now third property. Third property says median is dependent of change of origin and dependent of change of scale. We have already discussed this point in arithmetic mean as well. So change of origin means addition or subtraction of a constant. Like if we add or subtract a constant from all the elements of the series, this is called change of origin. And if we multiply or divide a constant from all the items of the series, then this is called change of scale. Let's take an example. Like we have been given this series, this is our X series. Fine. So what we are doing, we are adding a constant 2 in all the items of the series. So if I add 2, this becomes 7, 9, 13, 14 and 17. So if I find out the median of this new series, median is dependent on position. Position is third one. So my median becomes 13. So that is 11 plus 2, 13. If I subtract 2 from all the elements of the series, then it becomes 5 minus 2, 3, 7 minus 2, 5, 11 minus 2, 9, 12 minus 2, 10, 15 minus 2, 13. Again, the position won't change. So my median becomes 9. So again it's original minus the amount which has been subtracted from all the elements of the series. Now if I multiply the entire series by 2, so this becomes 10, 14, 22, 24 and 30. Again the position remains same. So my median is 22. So the thing is this, just understood the concept. If median of x plus k, that is equal to median of x plus k. Now if I say median of x plus 2, that is equal to median of x plus 2. Whatever the median you have computed of your original series, if we have added 2 into the series, then the revised median will be median of original series plus 2. If I say median of x minus k, that is equal to median of x minus k. If I say median of x into k, that is k into median of x. And if I say median of x divided by k, so that means median of x divided by k. Now what type of questions they can ask you regarding this property, because this property is there in mean as well, median as well, and mode as well. So they can ask you कि suppose the relationship between y is a plus bx. So if median of x is 5, find median of y. So simply you have to do y median is equal to a plus b x median. So if the question is this, the relationship between x and y is 2x minus 3y plus 11 equals to 0. If x median is 15, find y median. So you have to simply equate the value of x by x median. 2 into 15 minus 3y plus 11 equals to 0. 15 2s are 30 plus 11 41 equals to 3y. So y is equal to 41 by 3. That means y median is equal to 41 by 3. So these are the properties of median. First property, that is median can be determined graphically with the help of ogive curves. The point where less than and more than ogive intersects, that is called median. Second is sum of absolute deviations taken from median is always minimum. And third one is median is dependent of change of origin and dependent of change of scale. So these are the different properties of median. Now last concept of partitional average, that is merits and demerits of median. So first thing, again we have to recall the properties of good average. The first property is rigidly defined. Rigidly defined means unique value. So whenever you find out that particular average, you will get just one value. So whenever we compute median, we have computed median in n number of questions, always we have one single value of the series. There is not even one situation where we got two median. So that is why median is rigidly defined unique value. This is called merit of median. Now next thing is based on all the items of the series. So when we compute median, will we consider all the items of the series? No, we won't consider. We just consider the position at which a particular item lies. So we generally take the mid position and that will be the average. We won't consider all the items of the series. So that becomes demerit. So demerit is, it is not based on all the observations of the series. Third is extreme items. The median is generally the mid value, the middle item of the series. And extreme items are the smallest item and the largest item of the series. So if our range items changes, there won't be any effect on median. So median is the only average which is not affected by extreme items. We won't say least, it is not at all affected by extreme items. So whatever the extreme items may change, your median remains the same. So it won't affect our median. Next is sampling fluctuations. But so sampling fluctuations is the difference in values when we took multiple samples from a population. So if I have a population of 100 and I took 10 samples of 10 items each, and if their results are approximate to each other, then we say they are not affected by sampling fluctuation. But if results vary, then we say this is affected by sampling fluctuation. So median is the average which is least affected by sampling fluctuation. It won't much affected by sampling fluctuation. The results will be approximate to each other. So that means if we took 10 samples of 10 items each and we find out the median of each of these 10 samples, then you generally see that the result of median is approximate to each other. So that means they are least affected by sampling fluctuation. So then medians can be determined graphically with the help of ogive curves. I have already explained you. Median is simple to understand and easy to calculate, and the most important merit is median can be calculated in case of open-end classes. Open-end classes, the classes in which the first class lower limit is missing or the last class upper limit is missing. So whenever we compute mathematical average, it's not possible to compute mathematical average in case of open-end series. We have to make it closed. But because median lies in between the series, so if lower limit of first class is missing, upper limit of last class is missing, it won't affect, because we have to find out the class interval of middle one, and that is already given. So we can easily compute median in case of open end series. And the most important, median can be computed in case of quantitative data as well as qualitative data. Like if we have height, weight, marks, numerical data which is numerically expressed, we can compute median. And if we have qualitative data, data related to attributes, beauty, intelligence, smartness, X factor, so we can compute median of that qualitative data as well. So median can be calculated both in cases quantitative as well as qualitative data. But median is not capable of further algebraic treatment. Median is not used in further analysis, like max to max they are used in deviation, dispersion. But after that, in correlation regression, we generally use mean, we won't use median. So median is not capable of further algebraic treatment. And the most important, median do not possess any mathematical property. Do not possess any mathematical properties. Next one, bacha, median. Median, you can say it is not based on, it is not capable of further, it do not. The most important is whenever we compute median, we'll say the series must be arranged in ascending order. So if we have huge data, in case of huge data, arrangement of data in ascending order is very difficult. Arrangement of data in ascending order is very difficult. It's not easy to arrange data if it is very huge. So we can't arrange the data if there is a huge quantity of data. And one more thing, like in 11th you have discussed that if in case of individual series, if number of items are even, then you use n upon 2, and if number of items are odd, then use n plus 1 by 2 to find rank. No, this is not a correct thing. So don't take it in this manner. I have already explained you, whatever the number of items is in case of individual series, whenever you have to find out the rank, you have to find out the rank in the form n plus 1 by 2. So this is all about median, bacha. So we have discussed today harmonic mean and various partitional averages, median, quartiles, deciles and percentiles. In the next class, we'll discuss our last average, that is mode, and then we'll start the next chapter, that is measures of dispersion. So that's all for today beta. Thank you.